All right, step beneath the yellow tape, everyone, and welcome to this explainer. Today, we're opening up a very specific case file. You see, every single exam season, thousands of incredibly capable students walk into the Cambridge AS and A-level Mathematics 9709 exam, and they just hemorrhage points. And the crazy part, it happens on questions they swear they knew exactly how to solve. It's a massive mathematical mystery. So we're going to put on our detective hats and look at this like a real forensic investigation to find out exactly why those marks are disappearing into thin air. Let's process the scene.
Here is our investigative roadmap for today. First up, the incident report. Second, analyzing the evidence. Third, forensic reconstruction. Fourth, our live forensic workshop. And finally, we'll wrap it up with the final autopsy.
Okay, Section 1, the incident report. Let's start by profiling the failing high tariff question. To help us process this massive crime scene, I want to introduce you to two rookie forensic agents we've assigned to the case. Think of them as representing two very typical student approaches. First, we have Agent Alex. Now, Alex is totally obsessed with loose facts. He's always hunting for numbers, but he completely misses the bigger picture. Then on the other side, we have Agent Sam. Sam is all about vague theories, writing these elegant paragraphs, but completely forgetting to calculate the actual hard data. By looking through their two completely different lenses, we're going to be able to spot the extreme ends of common student errors, and more importantly, figure out exactly how we can avoid them.
So what is the exact culprit we're dealing with here? Well, it's Syllabus Section 1.1 Quadratics, and specifically, we're talking about simultaneous equations involving one linear and one quadratic equation. Now listen, I know what you're thinking. A lot of students assume, oh, this is just basic algebra, but let me stop you right there. At the A-level standard, this is about precise definitions, it's about cross-topic connections, it's absolutely not just about finding X and Y. It's about demonstrating a rigorous, systematic, logical framework to the examiner.
Moving right along to Section 2, analyzing the evidence. Let's turn on the UV highlighter and look at these student mistakes. I really want you to listen to this direct warning, straight from the principal examiner reports. Quote, examiners report that 1.1 quadratics is one of the most misunderstood areas. Candidates consistently confuse key terminology. Guys, this is a massive glowing red flag. When you're setting up your substitution, if you aren't defining your variables clearly from the jump, you are literally handing your marks right back to Cambridge. It's like leaving your front door wide open.
So Agent Sam poses this really vital question, and it's something we all need to think about. Why do students find multi-stage analysis and method marks so incredibly hard? Well, it's because most candidates think math is purely binary, right? You either get the correct final answer or you don't. But AS and A-level mathematics is an evaluation of your entire cognitive domain. It is testing knowledge, application, and analysis all at once. When students fail here, it's almost always because they simply cannot sustain a logical chain of reasoning over multiple, rigorous steps.
So, the absolutely crucial point is this. The Cambridge Assessment Framework prioritizes analytical depth over superficial breadth. Let me translate that from formal examiner speak into plain English for us. They do not care if you can memorize 100 different disconnected formulas if you don't actually understand the causal relationship between them. Depth means genuinely deconstructing the question. It means recognizing that, hey, a line intersecting a curve requires setting their equations equal to one another. Superficial breadth is not going to save you here. Deep, logical reasoning is literally your only shield in the exam room.
Looking at the examiner reports, we can actually distill the primary forensic evidence of student failure into 3 fatal drops. Drop number 1, forgetting proper format. This is when you do all the complex substitution perfectly, but then you leave your answer as some messy fraction instead of the requested coordinate format. Ouch. Drop number 2, failing to check presentation. Your working is just scattered randomly all over the page, making it practically impossible for the examiner to follow your logic. And drop number 3, answers not specific to context. Imagine you find 2 values for time, but one of them is negative, and you just fail to reject it. These 3 drops, this is exactly where your A grade bleeds out on the page.
Let's get into Section 3, Forensic Reconstruction. We are cracking the code with the standardized sequence.
Actually, really quick, before we reveal that ultimate decoder ring, a quick reminder. To make sure you never miss our explainer breakdowns and that you always outsmart the exams, hit subscribe to @AceTheExams right now and turn on all those notifications. All right, let's get back to the evidence board.
Okay, let's reveal the absolute holy grail the decoder ring examiners use. It's called the method marks strategy. Method marks are awarded strictly for the underlying analytical process, logical reasoning, and structured execution. This brilliantly illustrates that in Cambridge 9709, the journey is literally just as important as the destination. Think about it. If you make a tiny, silly arithmetic error on line 2, but you carry that error forward using flawless mathematical principles for the rest of the problem, the method mark strategy actually protects you. Process matters.
So, how do we capture every single one of those method marks? By following this 5-step sequence. Step 1. Identify and extract the equations. 2. Apply the relevant principles, like actually deciding whether to make X or Y the subject. 3. Execute your analysis by substituting carefully step by step. 4. Verify your formulas. And finally, step 5, format your answers logically, like presenting coordinate points if that's what's asked. Memorizing this workflow is like putting a titanium shield around your logic.
All right, moving to section 4, live forensic workshop. It is time for some viewer challenges right here in the exam room. Here is challenge 1. When a high tariff question asks you to evaluate 2 different mathematical models, what is the critical missing variable in a student's comparative analysis? I'm going to start a simulated 5-second mental timer right now. Think about it. Okay, time's up. Let's see the evidence.
Did you get it? The missing variable is connective logic. To score top marks, you absolutely must identify similarities and differences using comparative connectives that are supported by hard evidence. It is just not enough to state the vertex of curve A and the vertex of curve B as isolated facts. No way. You need to use comparative language, something like, whereas model A reaches a maximum height of 10 meters, model B only reaches 8 meters. Evaluative thinking requires you to question assumptions and justify your mathematical decisions.
Let's move right into challenge 2. I've intercepted a flawed student essay snippet, and I really need you to pinpoint the technical mistake that absolutely killed their grade. The student's approach was this, focusing only on isolated quadratic formulas without any broader context. They calculated the roots flawlessly using the formula, but then they just stopped. So why does this approach fail the Cambridge standard? What exactly is missing from the academic benchmark here?
Let's compare the crime scene side by side with the ideal scenario. On side A, we have the flawed evidence, isolated equations, missing terminology. The student treated the math in a total vacuum. But now look at side B, the high-scoring evidence, precise definitions, causal relationships, and cross-topic connections. A masterclass answer integrates topics seamlessly. It recognizes that finding the discriminant in a simultaneous equation actually tells you about the tangent to a curve, right? It connects algebra directly to coordinate geometry. The principal examiner reports definitively state that referencing cross-topic connections is how you achieve significantly higher marks. And finally, section 5, the final autopsy. It is time to lock down and protect the perimeter of your grade. The full mark blueprint dictates one very simple, non-negotiable rule. Always define terms before using them in extended responses. If you're going to introduce a variable like t for time or v for velocity while modeling a quadratic simultaneous equation, you must explicitly state what it means. Using clear terminology shows professional academic rigor. It proves to the examiner that you understand the actual language of mathematics, not just the mechanical operations.
To absolutely guarantee your success, I want you to grab a screenshot of this forensic exam protection checklist. It guides you from completely deconstructing the question to extracting the exact right data, selecting the proper analytical framework, and finally executing it with crystal clear notation. Following this ensures you leave absolutely no loose ends for the examiner to dock points.
So, case closed. Let's quickly summarize the 3 key takeaways you absolutely must walk away with from this explainer. Number 1, memorize the 5-step sequence for simultaneous equations to guarantee those crucial method marks. Remember, process over final answer. Number 2, use comparative connectives when evaluating models to really show off that analytical depth. And number 3, reference cross-topic connections to prove your overarching big-picture understanding of the syllabus architecture. If you master these 3 things, I promise you master the exam.
To ensure continuous forensic protection for all of your future exams, make sure you subscribe to @AceTheExams right now. Enable all those notifications so you are literally the first on the scene when a new case file drops. And hey, head down to the comment section below right now, report your current level and your target grade. Let's hold each other accountable and build a real dossier of success together.
I'm going to leave you with this final provocative thought. When you sit down for that Cambridge 9709 paper, what exactly is the examiner going to find? Will your next mathematics exam paper be a pristine crime scene just filled with fatal drops and stolen method marks? Or will it be a masterclass in forensic methodology that literally forces them to give you every single point?
The evidence is entirely in your hands. Now go practice those past papers, and I will see you in the next explainer.